All right, we're going to talk about the standard equation of an ellipse. First, let's talk about what is an ellipse. Now, in terms of the geometry part, let's identify a few characteristics of an ellipse. Notice that I've got two different diagrams here. One is a horizontal elongated ellipse and the other one is vertical. And in each ellipse, we have a major axis, which is drawn in here in yellow, that goes from this point, basically from the two endpoints of the horizontal part of the ellipse. That's called the major axis, and the shorter one, which is the vertical, in this case, is called the minor axis. Now, when I flip that and it becomes the vertically elongated ellipse, then notice that the major axis is vertical. Okay, and that is the entire end to end, from the top to the bottom part of the ellipse. That's major axis, and the minor axis is the horizontal one. In both cases, even though what you see, the center is at 0, 0, but the general center, just like a circle, we're going to label that HK. Now, obviously, you can see that the coordinate here is 0, 0, but for simplicity, we're going to call that HK, and then based on the major axis and the minor axis, we're going to write the equation of an ellipse. And here's the equation in the standard form, and it's given by this equation: x minus h all squared over a squared plus y minus k all squared over b squared is equal to 1, and is always equal to 1. No other number should be here. This is the standard form of an equation of an ellipse, and an A and B, they are the minor and major axes depending on if it's vertical or horizontal. So in the diagram 1, in case of diagram 1, the horizontal, the major axis will be the horizontal axis right across, and this A is actually half of the entire major axis. So 2A, the value of 2A from this point minus A0 to A0, so the entire thing, we don't know actually the coordinates, we're just in general, the entire length is 2A, and that's the value of major axis, the length of major axis for the elongated, horizontally elongated ellipse. And in this case, we have this equation set up, and A is half of 2A. And that's what you have to write up. For B, the same idea, but it's for minor axis. And so 2B is the minor axis length. So B is half of 2B, which goes from the center all the way to each one of these end values. So let me label those properly. So here we have minus 0 minus B, and on top we have 0b. So the entire thing is 2b, and that's the equation of an ellipse centered at HK. So now notice that in terms of the vertical elongated ellipse, the equation kind of doesn't change, but what you have in terms of AB does change, where now your horizontal, your major axis is actually vertical value. That means has to go under the y term. So B will be your major, not minor, and then your A will end up being the minor axis, will go under the horizontal x. So when you write this, you basically write the same, but now you have to be careful which one is longer, which one is the major, which one is the minor axis. All right, now let's look at an example of that. All right, let's try to graph this ellipse. X plus 2 all squared over 9 plus y minus 1 all squared over 4 equal to 1. All right, the first thing is we need to find the center. The center is given. This is x plus 2. Remember, the original graph, the original equation was given by x minus h all squared and y minus k squared for in terms of the center hk. But so the opposite, so x plus 2, that means the center is negative 2, and then for y, the y minus 1, the center will remain as positive 1. So basically opposite of the sign or the values that you see inside of the bracket. And then we need to figure out which one is the major axis, which one is the minor axis in terms of horizontal and vertical. So notice that 9 is bigger than 4. Now remember that this value has been squared already. So the actual A value, or the half of the major axis, which is going to be horizontal because it's under X, that's going to give you that the sign that is a horizontal major axis. So it's 9, the square root of 9 is 3. So we know that A, so the major axis is horizontal, and the value of that is 2 times 3, or you can just say A is equal to 3 for now. And the same thing for the 4. So that's the minor axis is vertical, and the value of that is square root of 4, which is 2, but we want to find the entire minor axis length, so that would be 2 times 2, which is equal to 4. So B is equal to 2. Now how are we going to graph that? So first, the center. The center is minus 2 and 1, so minus 2 and positive 1. That's the center. That's the first coordinate that we're going to punch in. All right, so this is minus 2 and positive 1. And then we're going to use the major and minor axes. So from the center, we're going to go to the left 3, 1, 2, 3. That's the 1 point on the ellipse, the end point, and then 1, 2, 3 to the right of the center. So that's the elongation, the horizontal elongation of the ellipse. And then we're going to go up to 1, 2. We're going to go down to 1, 2. And now we have this 4 points that basically the 4 corners, if you can call it corners, the top, bottom, left, and right of an ellipse. And then we're going to try to trace and do the best that we can to create an ellipse. And I'm using the dotted line, and here it is. Now we can graph this now and make sure that is correct using Desmos. So let's quickly do that. All right, so I use Desmos. Here is the equation with the center minus 2 and 1. Here's the center minus 2 and 1. And this is the most accurate, obviously. My original graph, as you can imagine, was not obviously as accurate. But here is we're using Desmos, and it's perfectly drawn, and it matches what we have talked about. So here it is. We have from here to here, that's 5, so that would be 3 units from the center. So that point right there, you can see minus 5. Yeah, and then here, that should be 1, 1. Very good. The top, you got 2 minus 2, 3, because it goes up only by 2 values. And so is that one. So here it is. We have everything set up properly. Here's the equation and the graph.